In this video, we are going to talk about the F5 ACI Service Center, which sits on top of the Cisco ACI App Center platform. An overview of the F5 ACI Service Center is that it is installed in the Cisco APIC controller and provides different features such as visibility, network stitching, and application services to the big IPs that are part of your Cisco ACI fabric. The big IPs could be virtual editions or they could be physical big IPs, and they could be deployed in any topology that supports or works in your environment. The entire solution is F5 supported. Now let's also take a look at the topology that we are going to be using for this demonstration. We are particularly going to be working with a big IP virtual edition, but in our environment, we do also have physical big IPs, and the workload that we are going to be working with is a virtual workload that's sitting in a VMware environment. The F5 ACI Service Center is already installed on the APIC controller. For the big IP virtual edition, we are going to be using a 2-arm deployment with client traffic as part of subnet 10.168 and server traffic as part of subnet 192.168. Before jumping into the demo, a good terminology to remember is what is an endpoint and an endpoint group on APIC and a pool member on Big IP. Now, an endpoint group on APIC is a collection of different endpoints, and these endpoints are basically your workload that is serving your application. Similarly, a pool on the Big IP is a collection of pool members, which is exactly the same workload that is serving that application. Hence, there is a correlation between an endpoint group on APIC to a pool on the Big IP and an endpoint on APIC to a pool member on the F5 Big IP. Now let's log into the APIC controller and head to the Apps tab where the F5 ACI Service Center is installed. Once we open the application, we will see that certain Big IP devices have already been discovered by the application. These devices have been discovered because they do have the LLDP protocol enabled, which the app is able to understand. Now, once we click on one of the devices and enter the Big IP credentials, the application will add the Big IP device to the appropriate menu on the left-hand pane. Since this is a VCMP host, it added it to the VCMP menu. Now we are going to log into a standalone virtual edition Big IP using the Big IP credentials admin. Now once we log into the Big IP, the view is similar to what you would see when you log into a Big IP, such as the host name, the IP address, is it active, is it standalone, etc. Now the three use cases, visibility, L2, L3 network management, and L4, L7 app services, are present as three tabs. But before we jump into the visibility tab, let's look at a scenario or a question that can help while looking at the visibility tab. Now, some of the scenarios or questions that come up is when I try to reach an application through the F5 Big IP virtual IP, the application is not responding. What could be the issue here? Is it a problem happening on the Big IP, or is it a problem happening at the Cisco ACI fabric? Now, using the visibility tab, we can see some of the information like what is the status of our VIP, of our pool, what are some of the connections that have been established, what is the interface status, etc., which can help us narrow down the issue and pinpoint as to where the problem is happening. Now let's go back to the application and look at the visibility use case. Now the visibility use case has three tables: VLAN information, VIP information, and node information. We are going to focus on the VIP information table in this scenario right now. So when we go ahead and look at the VIP table, We can also choose the partition that belongs on the big IP. Here we have common and a brownfield partition. A brownfield partition already has different virtual IPs, pools, and nodes defined on the big IP, and this view tells us exactly what node belongs to which tenant application and endpoint on the APIC controller. It also gives us the status of the VIP pool and node. Now let's take a deeper look into what is happening on the VIP as to why is it all showing red status. When we go to the visibility dashboard for a particular virtual IP, we see different information like the service port, the protocol, the SNAT information, which is automap here, the kind of route domain, and the default pool that is being used by this virtual server. It also gives us information about the stats on the pool as well as the number of pool members that are present. It also defines the monitor that is being used by a particular virtual server, and here it is the HTTP monitor. When we scroll down a bit, we can also see the APIC endpoint details as well as the big IP endpoint details for this particular virtual server. Here we see at the APIC endpoint details, we have the MAC address, the exact EPG that the virtual IP belongs to, the node, the interface, as well as the VLAN cap on the APIC endpoint details. On the big IP side, we also see the MAC, the VLAN, the interface information, and the self IP to which this virtual IP belongs to. Now going back to the APIC endpoint details, if we click on the interface, we can see whether this interface is up or down, is its admin and operational status up or down. Here we do see that it is a port channel and one of the interface operational state is down, and this could very well be one of the reasons that the application is down at this point. We see on the big IP side that the interface being used is up, and that is probably not a reason as to why there is an issue. The VLAN information on the big IP as well as the APIC endpoint also matches, so that indicates that the configuration from a VLAN perspective is correct. We're going to look into more details on the particular virtual IP. We're going to look at few connections that are on the VIP, and we see that there are no active connections happening to the virtual server. So we're going to look at the logs on the virtual IP to see if there is some indication as to what is happening on the virtual server. We will choose a date range and view the logs, and here we see that the monitor status had been changed from up to down, and then the status of the VIP changed from green to red and has become unavailable. So this gives us an indication that something went wrong with the monitor, so probably the HTTP monitor to the backend pool is causing an issue at this point. So we can go ahead and look at the node view at this point to see what do we see for a particular pool member or node at this point. So when we go to the node table and we head into the visibility table, we see that our node itself is green and it belongs to all those pools mentioned there as well as all the virtuals. But since it's green, let's click on the node and see what's happening for that particular node. Once we click on this node, it takes us to a visibility dashboard and tells us what monitor this node is using. And here it's using the default monitor, which is an ICMP monitor. So if you look at the connections to this node, we do see, yes, ICMP is working fine. So we are able to ping the node. So there is no problem with the reachability to the endpoint. So it clearly indicates that there is a problem with the actual application or the HTTP monitor to this particular endpoint. If we scroll below, we also see the APIC endpoint details, and the BIG-IP endpoint details similar to what we saw for a virtual IP. Here we see the interface that it's using is 1.2 and it is in status up. So let's look at the logs for this particular node as well. Let's choose the date and time range that works for us. And the filter is automatically applied to this particular log. Once we view the logs, we see that the monitor has gone down. The common HTTP monitor for a particular node has gone down. So this clearly indicates that the application that's running on the node is not responding to your HTTP monitor at this point. So let's go ahead and fix that. So we log into the endpoint, or we log into the application and start the HTTP on that particular endpoint. Once we start the HTTP or the Apache server on the application, we should see our backend nodes as well as our virtual IP back in a green or an available state. And here we see all our nodes, our pool as well as our VIP are now in available green state. All this information is being pulled from the BIG-IP itself. So every time you refresh this page, you will get the most recent information from the BIG-IP. Now, if we go back to the virtual IP and look at the visibility dashboard, we will see connections that have been established to it and the members that are available, but we still do see that one member is unavailable or still in the red state. So let's have a look at the statistics. So here we see that the first 4 nodes are getting traffic, but the last node, the .175, is not receiving any traffic. So this is another issue that we need to debug. So let's look at the connections now on the virtual IP. And here we see we have tons of connections, almost 212, going up to 243. And just at a glance, we see there are no connections to .175 and connections to all other nodes. So we go back to the application and go back to the visibility table and see what other nodes that are present for this VIP. And we here see only 170 to 174 and in fact do not see 175. So we go to that particular tenant application and endpoint group on the APIC to see what the issue might be. So once we go to that internal EPG on APIC and get into the operational tab, we see that only 170 to 174 have actually been learnt by the APIC. So our dashboard will only show information that is relevant to APIC and BIG-IP. So if an endpoint has not been learnt by the Cisco APIC fabric, that endpoint will not be present on the dashboard. So even though the BIG-IP has that as a pool member, APIC has not learned of that particular workload. So that is the issue that needs to be debugged on that particular tenant, app, and endpoint group. Now let's look at another scenario where the application can help. If there is a really dynamic application and there is workload distributed on different physical servers, VMs, containers, etc., how can the application automate pool membership on the BIG-IP to accommodate for this dynamic workload? Now, before we jump into actually looking at how to solve this, let's look at the implementation overview. We would have workload that gets added or deleted to an endpoint group on the Cisco ACI fabric. A notification is sent to the F5 ACI ServiceCenter, and based on the notification, whether it is an addition or a removal of workload from the EPG, that particular pool member gets added or deleted from the F5 BIG-IP. So in order to accomplish this, we must have a mapping of the EPG on the APIC to a pool on the F5 BIG-IP so that the service center would know exactly from which pool does workload need to be added or needs to be removed. Now let's have a look at the application and how we might achieve this. So this is done through the L4 to L7 app services on the application. And here we're going to add a new application and define the endpoint mapping as well. So we create a new partition called as dynamic endpoint. We assign it an application name such as web application. We choose a template in order to deploy the application. And here we are choosing a simple HTTP application. We define it a server port, a virtual IP address, as well as a virtual port number. Now notice here we do not define any server addresses, which is your workload or your pool members. Here we define the mapping of this particular pool to a particular endpoint group. So we select the endpoint group and also define the port on which we want our pool members to listen on. Once we save this configuration, we go ahead and deploy this on the BIG-IP. The deployment process can be monitored from the application itself. The request has been sent to the BIG-IP and the response can be viewed from the pending tasks. Once the configuration is deployed, it shows us a success message on the application itself. Now, once we have the application deployed, we can go into the application inventory and look at the application, the pool, the endpoint, etc. that we just deployed. And here we can view the endpoints that actually got configured on the BIG-IP, which is your pool members. So we see here we have approximately 18 pool members that get added to the BIG-IP. Let's take a look on the BIG-IP itself of what got deployed. So we log into the BIG-IP and go to the appropriate partition, which is the dynamic endpoint partition that we created. And within that partition, let's have a look at the virtual server that got deployed. And in that virtual server, let's have a look at the pool and the pool members. So as you remember, we did not define any of the pool members, but these pool members got automatically added based on the dynamic endpoint configuration that we did on the F5 ACI ServiceCenter. So all the members along with the port that we specified get added to the F5 BIG-IP. Now if we go back to the application, let's also take a look at what we see through the visibility tab for the application that we deployed. So once we click on the visibility tab and choose our appropriate partition on the BIG-IP, we will see that the virtual IP address along with all the pool members that we have deployed are shown here on the dashboard. We can even click on the VIP as we saw earlier to view more information about that particular virtual IP. Now the question is, where are these members coming from? So if we go back to an endpoint group on the APIC and go into the operational tab, we will see all the different IP addresses that are learned in this particular endpoint group. So the application is taking all the endpoints that are learned in this endpoint group and adding it as pool members on the BIG-IP. Now, as we remember the implementation workflow, any workload that from now on that gets added or deleted to this endpoint group will automatically be added and deleted as a pool member from the F5 BIG-IP. Now let's have a look at another scenario where we have a new BIG-IP to deploy within the ACI environment and how the application may be able to provide value there. So this brings us to the L2 to L3 network management use case or tab of the application. Here we do have to select a logical device cluster that we want to stitch with the fabric. And what the logical device cluster has, it has information about the VLAN that we want to associate with the F5 BIG-IP. And it also tells us that this logical device cluster is of type virtual or is it of type physical, etc. So we choose these VLANs that are part of the logical device cluster, and we can configure this information on the BIG-IP. Right here, using the application, we have already deployed self IPs and VLANs on the BIG-IP from the application itself. Now, the logical device cluster defined here is part of a service graph configuration on the APIC. Now, if we go to the BIG-IP to view the self IP and VLANs that we have configured, we see the VLAN with its appropriate tags as well as the self IP. Now, if we go directly to the self IP on the BIG-IP and change a value, we will see this being reflected in the application. And this is an advantage of configuring this information through the F5 ACI ServiceCenter. It is a stateful application, so any configuration deployed through this application will be stored in the application. Now, since we went on the BIG-IP and made an out-of-band change, we see an out-of-sync status on the service center. This gives us information exactly about what was changed on the BIG-IP, and here we have the option to sync configuration either from the BIG-IP to the application or back from the application to the BIG-IP. Here I choose to sync back to the BIG-IP because what I've configured through the application is the source of truth in my case. If we go back to the BIG-IP and refresh the self IP, we see that it's going to change the port lockdown back from allow all to allow default. Let's also have a look at some of the other functionalities of the Service Center. There is an export and import DB capability. Since the app is stateful, it does have a database, and if need be, you can import or export the Service Center database. There is also a topology map of the BIG-IP and the APIC available. So any of the BIG-IP devices that have been discovered using the LLDP protocol, there is a BIG-IP topology map which gives the different ports on the APIC as well as on the BIG-IP to where the connection exists. There are also faults that you can view of the service center itself. So any action or error that was encountered while operating the service center, you can see it in the faults for the particular BIG-IP for the different type of use case, visibility, L4, L7, or network management. A few key takeaways of the F5 ACI Service Center. It is a single point of automation with enhanced visibility into your Cisco ACI and F5 BIG-IP. It is suitable for both greenfield as well as brownfield deployments of your BIG-IP in your Cisco ACI fabric. If you have existing configuration on the BIG-IP, it will be able to pull that configuration and provide you visibility into that configuration. The use cases are not dependent on each other. You could use just the visibility or the L2, L3 or L4, L7 separately depending on what use case makes the most sense in your environment. The F5 ACI app is a stateful application and hence it is able to store information that you have configured on your BIG-IP. However, deleting the F5 ACI app will not impact any configuration on ACI or BIG-IP. The configuration that is done there will not be deleted if the application is deleted. Also, each of the actions that are performed through the F5 ACI Service Center user interface is automatable. There is a REST API endpoint to the Service Center itself. This app is fully supported by F5 and is present on the different APIC releases that are mentioned. The minimum BIG-IP release to have this application is 12.1 onwards. Hope this was helpful. Thank you for listening.